Hello, welcome everybody. We are close to some 20 in our audience here, which makes us very happy. We will today go through products, navigation lights, and not least the control and monitoring systems and installations of those two things in combination as what we call a system. We prepared a little PowerPoint show that I will start with, and then during the PowerPoint presentation we will switch back to the camera here and we can show you some hardware that we have ready for you to show on our table here. So Jen, will you start the PowerPoint? The idea is to enable you to install a complete basic system and the navigation lights. We hope you will understand the technical principles behind the systems here, and last but not least, enable you to give relevant advice to customers. So we're all certain that they are getting the absolute best possible solution given the various products and variations of that. The most important part here is the navigation lights. We showed just a few examples here. As you will appreciate from our website, web pages, there are literally hundreds of different combinations. In this seminar, we will focus on products that are meant for larger ships, and that means ships where there's a demand for what we call double lights with primary and secondary lights. So that is basic what we show here, but also a few single channel lights, in this case an anchor light. A Lopolight navigation light is actually quite advanced if you look at the electronics inside. There's an advanced driver here. It holds a microprocessor. It holds some constant current driver electronics meant for controlling the LEDs that are also sitting here, and we have some very specialized optics that will see so that the light we need is spread in the correct angles according to various standards, color and so forth. Now here you can see that it's quite simple. That light needs some power, 24 volt in this case, and that is the only two wires we have in the ship's cables going out from the control units that we'll come back to, and out to the individual light and light position. Some of the things the microprocessor in the navigation light is taking care of is to count running hours, and that's a little detail that we actually have to do according to certain standards, and to make sure that everything is running correctly and we are counting the hours. We count up to 50,000 hours. That's the lifetime of a Lopolight. We actually make a little self-test, or the light makes a little self-test in the first 5 seconds after being energized, and that is visible, or the OK signal is given by a small dip, a small blink in the light, and also in the power consumption, which is important because that means that we can detect that with using the navigation light controllers later on. So normally when you fire up a Lopolight, after 5 seconds you will see 1/10 of a second or 100 millisecond short blink where it actually turns off and then on again, and that is the positive identification that everything or the light is supposed to work as it shall. We use the same logic to indicate when a light is getting too old or getting close to the end of life, which is after 50,000 hours. 50,000 hours, that's a long time, that's many years. So it's not something you will experience the first many years. Actually, about 1 year, 2,000 dark hours before expiry, we make a little warning, and that means that we we widen this 100 millisecond gap to a 2-second blink. That means that this light is actually okay, but it will expire within a year if used on a professional vessel where we anticipate they're running all days of the year. After 50,000 hours, the startup blink will increase to 5 seconds. So here you have second number 5, you have second number 10 here, and that's a long pause to wait. That means the ship surveyors, they can look for this and see that the light is either okay or has gotten too old. And again, the monitoring electronics that we'll come back to in the navigation light controller can also detect these 3 different pulse widths. So that's a little technical thing that we have built in that no customers will normally be aware of or see. The electronics and in all the lights as another little hidden feature shown on the next page here. It is so we have a certain minimum intensity or power. And that, of course, is reflected in the number of nautical miles this light shall be visible. So if we have a certain limit here in the yellow, represented by the yellow line, if we just power an LED in the normal old-fashioned way, like many other people do, it will degrade over time. And at a certain point, it will actually provide less light than given by standards or even the Colrex. We can get over this by starting somewhat higher than the minimum level, and then just wait until it will hit the line. We do something else. We actually power the LEDs somewhat lower, closer to the minimum limit, and then every 2,000 hours we increase the drive current just a bit. So this is actually a little saw blade shaped curve. If we could see those details here. That means that we're getting a long lifetime out of the actual LED, and we have a very stable output. It also means that we actually increase the drive current internally in the light by these little percentages, but it means that end of life, an old light would use some 20-25% more power than it did when it was first installed. Again, a little secret that just to tell you what's actually happening in the internal driver. When installing a navigation light, you know how different ships and vessels can be. In some cases, you have a super yacht. They need an absolute minimal installation. So those customers would prefer a very low mounting base. We call it the K-lock bases here, and so we have them in different sizes with the cable glands coming in through the sides or up the bottom, and also some base plates that could fit various vessels in various ways. There are so many ways to combine all this, and again, it is important to try to tell the customer that there are things that can optimize every installation. The one mutual thing we have is what I call the K-lock system here, with this very coarse thread, as it actually is. It reminds of the way you mount a lens on a SLR camera. So they twist into this coarse thread here, as you can imagine. We use the same basic principle on lights for smaller yachts and for very big steel ships and professional installations. we have all these various things on stock, and it is from the data sheets on every light you can which you can find on our webpage. You can actually see the various options. So it's not just some option that one can order and hope that the manufacturer will make someday. No, it is in stock. You can get whatever suits the actual installation best. Here again in this seminar, we will sort of focus on larger, very often class of ABS recognized vessels. Here we show a trawler, a new build. It makes it leisure to install things in certain cases on a new build, because the naval architects would have made all the drillings and all the mechanical fixtures ready. But again, we have a large number of mounting plates and conversion plates, so it will very often fit existing hole patterns on if we're talking a retrofit. There's a lot of paperwork behind all this, and we have a lot of official reports and test reports recognized by class, by U.S. Coast Guard, and here especially U.S. Coast Guard recognition. So we can provide you with any kind of documentation that the customer or U.S. Coast Guard or other people showing interest in this, it is there. We have all the ammunition. Just come back to us if in case there's any doubt. It's all done in accredited laboratories. It's not something we just found out ourselves. Here's some examples. You have actually the light here installed on the trawler I just showed you. It's a new build. It's sailing in rough water, so this is not corrosion. It's just simply salt stains sitting on the base and on the conversion plate here and the side screens. Another example to the right, a retrofit on an existing steel ship where we produced a special very large plate to fit the existing footprint, and then installing our K-lock based mounting options on top of that. So it makes it as easy as possible for the installers to make the changeover to this technology. The control units, it's a story for itself. We have an extensive program that fulfills all the requirements given by authorities and class and what have we. It consists of a number of channels here, you can see, and we actually have one little, we call it a monitoring relay, the LMR, one per light. And that is, we'll come to that in a minute, but that is of course the unit that can pick up the blink signals that appears on the power wires when you fire up the navigation light. We use internally here an RS-485 protocol, good old-fashioned IBM invented thing, and that is very stable, and it's an easy to use technical network for these quite basic tasks that we have here. You can also see that there are two power supplies here. In this case, it's an AC. It can be anything from 86 to 264 volts, I think. That we provide power to the complete system, and then we convert that into 24 volts on the primary power supply here, and then there's a secondary power supply in case ship's primary power fails. Then we simply also change over, not even with a blink on the lights, because they're connected with, in parallel with a last diode. You have the circuit breakers in the lower part of the picture, one for the primary power and one for the secondary power. These, as you'll see here, all cables are terminated. Cables coming basically straight from the lights. They are simply terminated at little, it's actually connectors here at the side, so it's overseeable to install it. If I move on here, we can actually show you something here on the webcam if you pay attention for a second. We'll hopefully you manage. So, hi everybody. Here we have an open system that we can demonstrate live in a second, where you have the power supplies. We have under the aluminum covers that are normally sitting over these little relays here, a number of PCBs holding actually a little microprocessor that takes care of its own light. That means that we don't actually have a CPU sitting here. It is done individually, which helps a lot on talking about redundancy. You can see that's built in modules here. We have space for 14 cards on this side and another 14 over here. Everything is sitting on the same RS-485 bus. So when you go through and make an offer to a customer, we will put in exactly the number of channels that they need. They will not pay for anything that they don't need because it is in modules of 1. The basic models in motherboards here are of course in modules of 14, but that's not the big cost driver. You can also now, we have the webcam on here, you can see we have the control panels that is actually controlling the little cards here that then controls the lights. But we'll come back to that here when I continue with the PowerPoint show. So we're back here. There you have some physical installations on a new build where you can see the enclosure sitting, and there's a technical room just below the wheelhouse. Could also be in the console in the wheelhouse. Here a close-up real installations where you have all the ship's cables coming in from the navigation lights, primary secondary power supply, and the 2 circuit breakers. Fairly simple. So now we have, if you imagine the lights sitting at the end of these 24-volt wires, we have power supply. I forgot to tell that we can also use ships 24-volt if they use 24-volt as redundant power. Then we just change one of these to a DC-DC converter, and we do that in order not to share too much plus and minus with the ship's more or less dodgy systems. Here's an example of the wiring diagram. You can almost see how it resembles the actual layout, where you have the connections to all the lights sitting here at the right and left hand side, and then the various positions here. We always provide a customer-specific schematic that suits the individual installation. So, and we attach that to the manual that we hand out to you hand out to the customers when commissioning the system. So you can expect a one-to-one diagram, not a generic. Now it's getting a little more interesting. The control head. We have various systems to do two different ways of controlling all the LMR monitoring relays sitting in the navigation light controller, the NLC. As I told you, all these little cards, we have a little 485 bus, and that 485 actually originates from the control head, the keyboard. In this case, a push button unit that is very popular, physical buttons that we can, so we can control every individual light by for itself, or we have some programmed group buttons here that they're easy to set up the individual installation according to what the officers prefer. So when you're underway, you just press that one, and that will then provoke a certain pattern of lights to turn on. You program it basically like you did with an old car radio by pressing buttons for a long time, and then it will register which pattern to turn on when you use the group buttons. Now we're here. You can also, if you can see the text here, you see this keyboard is meant to control a fairly simple installation here: starboard primary, port primary, stern light, masthead, and so forth. But you will also see that we have a set of secondary lights here. That is the backup lights for controlling the double lights. So in this case, these two buttons, actually the two in the second and third row, they represent a same physical location of the light, but two different channels: the primary light and the secondary light in the doubled versions. The logics in this unit we define these two as being a pair, as we call it, and a pair means that the logics in here will know that this starboard primary light, it has a sibling that's the starboard secondary. So in case something happens to the primary light and the LMR cards reports back that it seems like a lamp is troublesome, it will give alarm and it will turn on the secondary light in the to take over the task of showing a certain color and certain angles at a certain place. These functions are actually quite standard and it's been that for years and years, and it's even described in certain IMO regulations, especially the one we call MSC 253, I think 6-page little piece of paper that IMO is issuing, and it explains basic functions of a navigation light control system. And all those functions are definitely fulfilled here and recognized by all kinds of authorities. When I send an alarm that will turn on, an alarm button that will show red light when you see an error. I'll show you that later on the hardware we're having here on my disk. Here you have the primary, secondary, and again represented by certain text on the keyboard. And again, a light with a primary and secondary, when we call it that, it is placed at the same position. Same position means, in this case, starboard side of the light, because it's a starboard light. And it's really easy for us and for you to configure what is what. Another thing that can be configured is, first here, the keyboard here is supposed to be placed at the conning station, quite close to the wheel, as in this example on a new build boat. The keyboard, we have it in 3 different basic sizes, but I'll come back to that later also. But basically, a maximum 28 channel keyboard, or a maximum 21, or a maximum 14 channel keyboard. So we can optimize, again, we can optimize each installation fairly easy. The text you see on it can be configured and given by the customer, and we simply make a custom engraving of each and every project. Here you have the simple system. You have the center of it here. That's of course the assembly of these monitoring relays, the LMRQs we call it. You have the power supplies, circuit breakers. So just provide this with either AC or DC. depending on how it's configured. All the lights are connected to the physical locations here, the other side. And then we have just a thin data cable going all the way up to the wheelhouse. It can be very long, RS-485. You can use that over, I don't know, 3,000 feet or something. So it's really uncritical. And install the push button panel here. That's it. It's really the big thing is, of course, to have the nav lights installed physically with all the boltings and choosing all the correct base plates. That's how simple it is. In this case, in this simple case, we have just one panel, but you could imagine an installation where you have a double end of ferry and they would like to have a replica of this, and the other wheelhouse, that could be the other end of the wheelhouse, so you can actually operate the system from two different conning places or even more. Which you have here is very easy. They're hooked up on the same network, conning A, conning B. And you will see that here on an example of a very large installation where we have a double end of ferry, in this case a new project, that's the new Staten Island ferries in New York. As they go in both directions without turning the ship, there's an awful lot of lights on it. We have side lights, port and starboard, going in New York direction. We have the same set in the other end of the ferry when they go direction Staten Island. And all these are doubled lights. So on a ship like this, you would have basically 4 starboard lights that are all operational. Although 2 and 2 they will never be turned on at the same time. If you look at the wiring diagram on a more complex installation as this example with a large ferry, we have 2 conning stations. We actually split the system up so they have one panel controlling what we call signal lights. That's typically all-round lights for showing not under command or anchor situations, and then one for what we define as navigation lights. Those are the starboard, port, stern, masthead lights. So that's a big system with a total of 4 panels, and we also split it up into 2 different navigation light controllers, the NLCs here. And to make it even worse, we have repeaters showing what the panels are showing down in the engine rooms, so that the engineers, they will have an idea of what way they're actually sailing right now. So that's a good example of a more complex thing, and of course it is something we would always be involved in to help help and set up things here, as some of you will already know. These are one of the diagrams that we delivered to the yard, simply so they could prepare all the correct cables when pulling cables and doing all the preparations before they actually had the equipment sent over. It's not so bad after all when you see the physical parts. Here you have the 2 NLCs. You have the panels for conning station A, conning station B, some little assembly boxes here just to assemble the network and the power cables, and the repeaters that goes into the engine rooms. In this case, it's actually a little more sophisticated because we install what we call ice class lights on these ferries. That means that they can actually defrost in case of ice risk. But that's another story. It just means that we have to put in somewhat larger power supplies, because we can pull a lot of power when we fire 20 watts in every light to heat it up. But that'll be another story. Now, let me go back here. Maybe we should take the webcam again. So now we're back to some physics here, which I turn the camera where we have the LMR cues again. We have the control panel. And if I now turn on the light, let me see what is side light, port side. So this will now transmit a 485 telegram that will hit one of these cards. Maybe you can see that little thing here illuminates. That means that this card's output is active and it has turned on the primary sector of the port side light. I can turn over to shift over to the spare light, port side spare light here, and then and that would normally happen automatically in case of an error, which I can show you here. Now we have the primary on. I'll try not to blind the camera too much, like this. And if I now provoke an error simply by pulling the wire to the test light here, the light goes out, of course, and you will see that within 5 seconds it will make an alarm. It will energize the general alarm button here. We can mute the audible alarm as we're supposed to. It's all given in the standards. We still indicate what light is failing and also that the spare light has cut in. Now in this case I can turn off the failing light and everybody is actually happy so far. Of course the electrician will have to take action the next morning. Now I can repair our situation here by reinstalling the power connector. So, and everybody's happy. Another function, this was a pair function. Another function is if we use the group buttons here, we just press underway and then a number of lights will turn on here. Now the starboard light also came on, stern lights and all that. That's bothering the camera here. And here the big mastheads that we have to turn. So again, an important thing is, that's an awful lot of light there, that we have this basic cable going from the panel to the controllers here, and that's just a simple little 7-wire cable that we normally provide in the desired length. Staten Island case, it had to be installed before. We'll just wind off the windows here. So, and as you can see here, I just pulled it out. That means, of course, there will be no action possible on the keyboard because it's dead. It's just hanging here on a loose data cable power. But we can still operate the lights using emergency switches that are sitting here, normally protruding through the aluminium cover that would cover all these electronics here. So was it this one? Yeah, it was. The port side light, we can turn it on here, off again, and that means we can operate the complete system even if something should happen to cables or data communication and all these wonderful things. So it's and again, it's not something we have to boot or anything. You just put it in again, and in a second, this will be live again, and everything will work. Yeah, yeah. So it is. It's a very stable system that is not depending on very much. You can always, so the customer can always move on and still be absolutely sure they show the correct light, which is absolutely important. They're not allowed to leave port in case they don't show the correct light at night. Another little thing here, there's a dimming of the indicators here, and it dims all the way to 0, again given by the various descriptions that we have from the authorities and IMO. Now, the next part here is based on the fact that we take away this keyboard, which is the basic solution, and we will introduce another way of controlling it using a touchscreen system we have, which is quite amazing, and enables you to, or the customer to have a much more detailed control, and it is something many customers they require these days. But let me get back to the PowerPoint first, and then we'll come show you some of the hardware here a little later. So now here we are. If I go back here now, you can see we have a basic system built up to control a touchscreen. It works quite differently from the push button panel, but we share the simple installation of the lights, exactly the same navigation light controller here, but now we have a little Linux computer that is extremely stable, and that is actually a web server. That web server will push out a picture of the ship in question. The good thing is that we can just upload a picture here of the individual project, so the customer will have a mimic of their own ship. We have chosen a way, so we actually just use a very simple monitor, because we have a little web client here, also an industrial Linux-based thing. So we have one Ethernet going from the server and over to the little client, and then serves the monitor with a normal HDMI or any other video signal. One little thing that's important is that we actually, the way this works is that we're pushing out as the software guys call it, any change in status, which is important. If something happens, we have to show which light that creates an alarm. As you can imagine, when I go to the next slide here, we can put a little switch in between the server, and then we can have multiple clients. In this case, two. That could very well be the New York Staten Island thing. When that was planned, we didn't have this project, but that would have been a very good solution. So it can be, it's just now here we show a little waterproof and some industrial type switch, but it is just a normal Ethernet switch that anyone can use or source from wherever. Of course, outputs for alarm buzzers as well. Yeah. So it will coming back to that ferry project, just to mention that, because it's an exciting project for us also. Everything has actually been planned in the sense that we have requested cable laying at that time, so we can actually install this instead of the keyboards very easily when we come to that. As you can see here, we also mentioned that we have an NMEA output here. That's a simple old-fashioned 0183 NMEA, and that means that this unit will constantly spit out current status of the complete system. So if one navigation light should create an alarm, that a standard NMEA telegram will tell that. We actually do the same on the keyboards, the keyboard models. There is also a standard NMEA interface that's always running. 4800 Bo and the usual story. The keyboards, we have a few extra options using that, but that'll be another session. Now, if I continue here, here you have an example of the It's the actual touch screen here. The customer was a, a tugboat operator. And you can see that we represent, instead of illuminating the keyboard buttons here, we represent every light by a colored dot at the actual position of the ship. That is appreciated by many customers today. It is, that system can be customized in so many ways. First of all, the picture of the ship here, or the mimic of the ship, but also how we represent the lights. Here's simply a little GIF that we use, but we'll come back to that in a second. When we set it up, you remember from the keyboard panel, the button panel, that we have groups. That we can use. Here we define them ourselves when we set up the system, and you can do that. You're supposed to play with it. Where we define what happens if I'm underway. I just push this soft button, or at anchor, or towing, or whatever situation whatever situation the ship will be in. I'll continue now here with the NLC, which is again very important because here we have all the hardware installed. I told you about the LMRQ sitting in here, or the LMR, these monitoring relays, one per channel, and they are quite advanced, although it's just a little microprocessor-based unit with a little driver and things. Here you have it. That is the important little thing sitting there. They need an address, and we set that address up in a good old-fashioned way by use of a dip switch. So in this case, this card has been assigned address number 6 because it's binary, 1, 2, 4, 8, 16. Forget about these numbers. So here it's 2 and 4 combined. That means binary 6. All cards in the system have individual addresses. I told you about the manual switch sitting here. That's the one you can access even through the aluminum cover. But we have another important thing, that's the teach-in button. The way we designed this is that when you install a system for the first time with the lights, everything's connected. You turn on a certain light, you make sure it's working, and then we, after following a certain procedure that's given in the manual, we press this little teach-in button once. And that means that the processor on this card will register the specifics of its own light, and that enables us to give alarm if the power consumption, or actually, the power consumption given in watts, if that drops some 15% under the value that was registered when we made perform this teach-in operation, then an alarm will be given next time the whatever control head is asking on the RS-485 bus how it's doing. There's a little indicator, as I showed you, the green thing, or red when we introduced the error, simply a little LED sitting on the front. So that's an important little thing. It's easy to have a few spare ones in case something happens, although it is not very likely something happens to this card. It is very rough. Here you have the system again. Any kind of control head. We have the RS-485 and the power that powers we can even power the monitor directly from the NLC. Of course, it needs some 24-volt power here, and the outputs. I go on, turn on to the next one here. More of the qualities of this one. It's addressable with the RS-485, of course. It is short circuit proof and reverse polarity safe. Short circuit safe means that even if you shorten the supply wires out to the lights, it will see that now a current of more than 2 amps is being registered, and it will turn off the output, not destroying the drivers in here, or the output components. So actually one can work on a system that's powered. It's only 24 volts, so it's not dangerous. And if you make it short, it will register during stripping wires and connecting to the terminals in the light. This one will cut the output and wait 30 seconds, and then we'll try to re-energize the output and see if there's still a short. If there's no short anymore, then just delivers the 24 volt out to the light. So you can say it's a highly sophisticated automatic fuse. It will give an alarm if power is less than the 15% detected at the teach-in. It makes an alarm if it does not see the startup blink I told you about in the beginning. It will accept that the light increases slowly in power consumption over time, because of course the software here is aware of the fact that we actually or the light will actually start to use more power over a long time. It can accept de-ice extra consumption on ice class lights, which is of course an important thing. It can control dimmable lights for SAR and Navy use, but we'll come back to that at another session. And then we can operate things manually. As this unit expects to see a start-off blink, it will not necessarily work 100% with the lights from of other brands, because they use other ways, I'm sure, than we do. But there. So it is a Lopolight product that are supposed to control Lopolight navigation lights. When working on a project and you need to specify all this, you will need some communication with us. We cannot very often come up with a suggestion when we hear of a certain project, a certain ship type. We have a lot of experience in what is normally used. But the customer, and those customers, or the guys you're talking to there, they know a lot about rules and regulations and what they need to have. So it's good to be well prepared, and we can assist very much in that. We actually have on our webpage, we have a specification form where you can go in and say what text is needed. Very often we would come up with a suggestion first. We have learned over time to what works best in many cases. But here we can also specify input voltages for primary supply, input voltages for secondary supply, so we can install the proper power units in the navigation light controller in the steel encapsulation there. So here you have again the basic the options: the maximum 14 channel, maximum 21 channel, maximum 28. It's just a width here. You can see one row is disappearing when going from 28 to 21. And here the power supplies we build in, seeing to that everything is rated for a given project. So you could say the customer specifies, and it would be good if you can help we can help specifying all this: basic panel size, the text to be engraved, connection cable length. That means the connection cable from the control head to the NLC. primary, secondary power supply, we need to know about that. We will then make project customer-specific schematics, and we also need to know something about whether the customer prefers a steel enclosure that we can deliver or just open frame. In many cases, there would be a big enclosure for other electronics, and this will fit in wherever suitable, and there's no need to add a big steel cabinet in certain cases. So we can come with both. Again, here the schematics and the engravings. So that was the slideshow with all the basic principles here. We have a lot more to tell you about ice class installations, certain dimming ways we can do Navy and SAR products, how to use the NMEA on the especially on the push button panels, and of course we would appreciate to present a lot of other Lopolight products that are not directly called navigation lights. Certificates, in certain cases it would be customers would need a thorough walkthrough through all our test reports and certificates, and we can all come with a long song about that. Troubleshooting, if you understand the principles here, it's fairly straightforward, but that would be a little session we can take one day. So if I go back to the webcam, yeah, we are again, and we shall see that we don't make too much noise. Yeah. Here, here we are now at a. Well, I took off the keyboard, and now we're back to a monitor here. Real time, it happens to be the same picture as you just saw, and we'll get back to playing with that one. We'll just get that on your screen. But you can see here we have the little web client that is hooked up to the web server, controlling the whole thing here. So it is actually live things. Now allow us 2 seconds here to get the this monitor up on your monitors. So here you are. Here you have this little tugboat. It could just as well be a double-ender ferry. It could be a super yacht. And as you will see, you saw the lights on my table here. Those are exactly the one represented by these indicators here.
We'll turn on the webcam.
Now you should also be able to see the webcam here, where you have the actual lights here in front of you. You can see the little port light. That's a good example because it doesn't disturb the monitor, the camera too much. So if I turn off on the wait button here, all these will go off, and you can actually see in real life that they are turned off. I can turn on anchor, and that will turn on an anchor light, and also give the visual indication here on top of the vessel. You may have noticed when I press the button, it starts in red, and that's quite interesting actually, because it will not turn green until it has received an OK telegram from the little LMRQ. So it's a real. Now turn off that thing. I turn on underway now, and you can see it starts in red, and then it turns green, indicating that it has a positive feedback from the LMRQ the microprocessor, that all lights belonging to the underway group are actually active. Now here we can do many things. We can control all the lights individually. The top bar, that's the thing that we have to do. It's mentioned by some of these standards here. So here I can turn off the lights individually. And if I go back to the main page, you'll see that now we're not showing underway anymore because we're only showing one starboard light. This group button is expecting other lights to be on, so I just turned off. That was simply because I now used, I bypassed the group buttons by going into individual lights and controlling things directly. We don't forget that we can still control the lights on the hardware buttons here. There's an alarm lock, so in case something has happened, we store exactly what has happened, when it happened, and that alarm lock can then be very long in case or many years, and you can clear it here. Now it's clear all alarms, and now the lock is cleared. I go to the main page here, and now to the interesting part. That's the manage side page here. The manage page requires a password. Now here you have a lot of technical information. Here's what we actually received back from the LMRQ. So this is a technical page that is not supposed to be used by the navigators, but is definitely to be used by you when commissioning the system. When setting up the first time, we press this detect addresses here, and it will then find out what LMRQs are actually present.
Webcam.
So we report back certain things about the protocol that we use can be used for fault finding. If I turn on a light here, let me take the 4 masthead here. It's turned on, and you can see that we actually report back what are the voltage on the output terminals of the LMRQ, and the current that we're right now is actually registering being used by the given light. If I take another one here, that one here, you can see it's quite another current, but still only some 350 milliamps here. So it's not big. It's not big currents we're talking. There's a temperature here. It's a little leftover from some military lights, but it's actually the temperature of the microprocessor on the LMRQ. But never mind. So here you have all these wonderful things. If we installed another channel, a card number 15 on the other side of the NFC, make a new detect addresses here, then that would appear down here as number 15. And we can control up to 60 lights with this system. So it would just mean that we make a setup. If we take the ferry example where we have 2 NLCs, they can easily be put in parallel, and we just make one new detect addresses, and we would have all lights, including all the signal lights, on the same list here. We can go in if we need to change the ship's image. We check here, and then we choose the file from our PC that where we're setting things up, and we can upload another image very easily. We can choose which indicators that we actually show when we turn on a light. In this case, we have a little red dot here typically for a port primary. We have to make a choice here. Good, we'll take the stable one for if everything's good. If it's in fail state, we can make it blink. It's an animated GIF. You can add your own here. You can do whatever. Here we have a little selection of what sometimes makes sense for us, but it could be absolutely, it's configurable from your own computer. If I go back to manage, så vil snart strømmen den derovre.
Den holder sig.
So here are all the individual buttons, the addresses, all the lights. we can do pairs. So actually, when I come back to making a group button here, we have a pair name called, let's say, masthead, the top masthead here, or the fore masthead. And that consists of a primary and a secondary light. And the same with all the others that are in pairs. It could also be a single light, then it's not in a pair. It's fairly simple. So I go back to the light groups now, where here you can see that we have, in this case, an underway button, an anchor button, and a towing button. If we go in and edit the underway button, and don't forget that the underway button is the one we see down here, the one we press, and it will turn on the whatever pairs that belongs to this button. Go back to the manage page, light groups. If I now edit that, or create a new one, we have to define what happens if we press this button. There are groups, there are other groups. There's a master towing group, there's an anchor group here. What shall we do? In this case, just to play with things, we have told them, we've set the system up so it shall turn off the anchor group and do nothing to the masthead towing. Other pairs here, we turn off, when we press the underway button that we're editing right now, we will turn the towing light, masthead towing off, turn on port side light, turn on starboard side light, pairs, and some individual lights. We haven't chosen any here. So we have three actions possible when we press a button. It can be turning something on, off, or no action. In this case, we choose off. So if I go back to the main page, you will see here that when I press anchor, it's been programmed in a way that it will automatically turn off underway, do nothing to the masthead towing here, or vice versa. When I press underway, the example we just saw, it will turn off the anchor group and on with this one. Could also go in and say, now we make a new one. It will take a little while, but what happens is that we say create a new group. What shall it be? It could be not under command. Encapsulators, and you see, and I save that. Now we have another group that has appeared. We can go in here and check it. We have the NUC light here, but there will be no action on it because no lights are assigned to it. So it's uncritical. Go back to manage. As long as the password will be stored for 10 minutes of inactivity, if you will. So I can go back and forth right now. If I wait 10 minutes, then I have to key in the password again. Light groups, NUC. Okay, what shall happen? Let's say that we don't do anything to the underway status. We leave it as it is, whatever status that may be. But we could turn off the anchor light, just to play with things here. And then we shall now say we turn on say I don't have a nuke light right here on the demo set because it would take an awful lot of wires on my desk. But let's say we turn that one on. And we also turn on what can we take? It could be one of the lights they were already used. Could be the starboard side light. So those two, they are now assigned to this group. Save. So the anchor light, don't forget that we turn off the anchor light. No matter what, we do nothing to the underway buttons here. And if I go into main, you can see that now we press the. Let's move this one there. Everything's off, underway, those two here. We can turn on an anchor light. That will turn off the underway lights. with the logics we just created, and if I press the not under command, normally it would be 2 red buttons here, but I don't have those lights here on my table. So not under command, it turned off that one, and it actually turned on, in this case for the example, a starboard light and a stern light. So that's how the logics are. You can combine this in so many ways and set it up until the customer is satisfied, and when he is satisfied and things are turning on and off as supposed to, then we press export configuration, and you can save that configuration in your own setup PC. Your own setup PC, when you set this thing up, if I go to the I need the very last page of the presentation again here. That would be
that one.
Like that. Just a second. Yeah. Now, here's a little fun thing we can do, because as you remember, we had the switch here, we have the web server that's connected to the NLC, and then our client. Now I opened our router and we actually connected our internal network to this switch, which is normally absolutely forbidden, and don't ever suggest that on a ship. So now we have a public ID here, or a public IP address here. So if you have another device next to you, it could be your telephone, it could be your another computer, or whatever you have, then if you enter this IP address here, press enter, then you are in absolute control. Now we are quite a lot of people here, so you could tease each other a lot, but you can actually, as it is IP technology, you can control this thing. Now if I hook on the webcam there, and you can see the lights, you can see the starboard light there, you have a port light, those are good examples that you can then address using, but it is not a desktop connection here, so a remote desktop. So I can't see what you're doing, but I can see that you're turning on and off the lights. So it resembles the situation where we have not a 2 conning station system here, but a 10 conning station system. The password for the setup and the managed side is 1234. And if one of you go in there, another one can go in and make other changes. It will not disturb each other. So, but it's quite fascinating when you see that you're actually pressing the button sitting far away, and you can control the hardware right here on our desk. And you can see on the monitor we have here, it is following exactly what you're pressing. So if one of you are pressing one of those, this one resembles the physics of it. So here you have it in full size, where you have the lights hidden there. So again, I hope you will understand that this is the internet connection is something we do here in our little closed forum. It's not something that's supposed to be. One can imagine many fun things with this. So if you go into manage, one of you, well, I can't see what you're doing, because again, this monitor is just as though as I was a navigator in one end of the Staten Island ferry, and someone else is doing service somewhere else in the web server. So I can't. It's not a remote desktop where I can see what you're doing. So you can set up a new group if you like, and that group would appear, if you set up a new group, that would appear on my monitor here. Yeah, now we have the not under command here, or delete the not under command for that sake. If a new group is set up, I actually have to hit the main menu again here. Well, now we have it open for your microphones if you want to talk to us, but otherwise we just make sure that you get the information and all the material after this session is soon over. But we're supposed to be able to hear you now.
Are these panels available now?
Yes, they are.
What sizes are available? What sizes do they come in?
It's not so critical for us because again we deliver the little web client here and the server and that's fairly easy and the monitor is then sitting on the HDMI output, so it could be any monitor. The thing is that the monitors will have to or probably have to be class approved. We suggest Moxa or Hadeland. Here we show a 15-inch. We could provide it, and we would have that in stock in 10, 15, and 24. We do have 15 in stock right now, but it's available. So it could be basically anything. Little thing we saw actually on the trawler I showed you is that other companies are making some screen sharing systems, so you can present your chart, you can present your trawling monitors or whatever at a huge big video system, and we can actually just provide video for that system too. So there are so many ways to combine this. And again, the monitor, you can choose a monitor, we can deliver it, but be aware that the customer may find out and already know that it has to be thoroughly approved, which always means something for the price.
A comment on the screens. As you can see when you're operating your own screens here, that we're not really concerned about the screens. The logic behind it is important. The only thing that you should so we can use the system that's on board and make sure that that it's compatible with the aesthetics of whatever that vessel wants. But what is important for you when you are working in installation preparation phase and you want to calibrate the monitor of that vessel is that you know the screen aspect ratio. It would be it's a little bit awkward if you prepared a 4.3 and you find a 16.9 and then the width of the actual image of the vessel will decide how much room you have for the buttons. In some cases, you would have to increase the width of the image to make the image slimmer to allow for more buttons. But that is details in the application.
Jens said for setting it up, we could be helpful with that, but it's just a PNG or any picture, could be a picture of Jan or me. It's uncritical. There can be colors in that picture. We think it looks the best with the white on black outline, but it can literally be anything. It's just a background picture.
I have a question.
Yes, sir.
Let's say they have a integrated monitoring system on the vessel. Can you integrate your system into their monitoring system?
Yes, very often that kind of monitoring system would be based on the NMEA data that we supply. So if it's a monitoring system monitoring alarm conditions, that can listen in on the NMEA interface we have on all the systems here as standard, and it will come up with whatever status is present. There are many there are many standard sentences that are defined in IEC 61, whatever it's called, including navigation light controllers. The thing with the button panels, we can actually remote control the button panel via an NMEA interface. So you can send a special telegram that tells, let's say, a certain group button to be activated or deactivated. It works wonderful, and quite a few people do that actually to integrate it. We don't do it on the touch panel systems because it doesn't make sense, because then it is the control system, the most advanced one can think of. So the answer is definitely yes, and it happens, and it works very good. Could also be output for VDR. They will also understand the standard telegrams we're sending out every second as the normal NMEA 0183. We can also mute the audible alarms on the keyboard panels. We also send out on the NMEA a standard agreed upon telegram. When we press our mute button, it could actually mute other alarms on the bridge as well. So that there are certain details in that, and we can send you a protocol. Just come back to us, and we'll see that you get that.
Got a question for you. I think you mentioned at one point that you can do up to 60 lights on the glass bridge nav light controller or display. If you have more than 60 lights, are you required to get a new display or an additional display, or how does that work?
I can't imagine more than 60 lights, I'm afraid. So it would be.
No, I understand. I was just thinking.
But we have. When we designed the systems in the beginning here, based on the keyboard panels, we thought that 28 that would be the absolutely maximum, and it does the job in most cases. And then comes, of course, these very specialized fares and things, and then we need some, I don't know, 36 channels or something. So I still think we are on a we have not heard of anything going more than, let's say, 40, 45 buttons.
Understood.
And we have seen a lot now.
In working on refit projects, what size cables will the Lopolights accept for vessels, for using lights on vessels over 50 meters? You can give it to me in millimeter squared, or you can, I don't.
Yeah, but we have no lights that are using more than 600 milliamps. Even the biggest mast sets, they're using less than, I think, we could see that. But you can actually see that if you go in. You can see what they uses on 24 volts if you go into the managed side.
Okay.
And that means that, let's say, 1 amp the maximum. So basically a 1.5 square millimeter is more than sufficient. A good thing is also that the light is not, most of the lights, the masthead, it would work from 19.5 volt and up to 32 volt. So even if we have a voltage drop, the intensity would be exactly the same. The internal driver will see to that the LED is getting what it needs. If the voltage drop is big, of course the current will go up because we need a certain power in watts. That's the physics of it. So there's no case where we cannot do with the existing wiring. There will always be bigger, because there could be other local rules stating that there's a certain minimum gauge, and that if that minimum gauge is already installed, then it would for sure be more than we need physically.
Yeah, I'm just thinking that for vessels that have existing lights, the old aqua signals, using halogen or xenon, the cable is going to be very large, maybe an AWG 14 gauge or even 12 gauge, depending on you know, the
Yep.
lengths from the
Very old
control
part.
panels.
Yeah.
Especially the old fat, whether you have an incandescent installation and you have a 1,000-foot freight ship or tanker, and the spare lights would have been, in some cases, 24 volts, and they needed 100 watts. That's some 4 amps. But 1,000 feet out in the foremast, then you really see some heavy gauge there. I know, but it's more than enough for us, of course. We do have some bases where we have very large cable glands to be able to take those cables. So the cable can be terminated in one of the types of the that we have here.
Okay.
It's just the base, and then what happens inside the base, that's much more easy for us to handle. So those K-lock bases.
Can you show a base as to what it looks like as terminating on the inside of it?
When you have the base here, where you have various cable glands, you can see here various examples here. Another one here with the heavy gauge cable glands. It takes up to
A half inch.
no, it's
More than half inch.
no, it's more than 16 millimeter. This is half inch.
Yeah.
And the idea, if we have the little screwdriver here, just a second. Again,
Sorry,
you can see you have the base here, or some kind of base, and then you have the light that could easily look like this. And it goes into the base. There's an O-ring seal, and there's actually a little locking screw here to put in the exact correct position. You can see that locking screw there. If we take that out, you can see what's in the base. So there's room enough in the big bases here, even to take very large diameter. You see the O-ring here, where you have all this room here. Here it is. Sorry, the room here for making whatever is needed until going on to the connector we have in the light.
Excellent.
So that base acts as a junction box.
Yeah, it does.
Yeah,
It is.
okay, that was my original question. That's pretty good. Is there any class, one last question, I'm sorry, is there any class regulation that says a double light, which has to be the primary and which has to be the secondary?
Nope, doesn't matter.
Either top or bottom?
Doesn't matter. And the thing is, when you have a double light, like all these here, now we say that they have a lifetime of 50,000 hours. Something else would probably have happened before that, but still, basically you could, after 30,000 running hours, which you can always read out in the especially on the glass bridge systems, you could swap the channels very easily simply by swapping primary and secondary here, and then you would have a brand new light that could do another 50,000 hours. So you could land up in theoretically 100,000 hours burning time on one position, because you just swap the definition of what you define as being the primary.
Very good. Thank you.
If you do that swap, do you have to reteach the light now that the bottom light is the primary and the top light is a secondary?
Yes, because at this time the degradation control system would have increased the drive current by some 20-25% on the until now in our example here, with some 25%. If we swap those two channels, then we would have to make a new teach-in because we also have a maximum limit actually. So it would make alarm to now it's getting an absolutely new lamp put on, and say it will not use enough power.
Gotcha.
That's one of the little things that this LMR does. When you press the teach-in button, you have a certain power consumption, and we put in a minimum and a maximum limit here, some plus minus 15%. So now the drive current goes up slowly, and we move these limits Never down, but we can do it upwards and only at a very slow pace. That's in the logics of that thing. Now, if we put on a new light, it will have this consumption. That will create an alarm. But it's just pressing that little button. And on the glass bridge systems, you don't have to press any button. There's a soft button where you do that. You can, if you go into manage on the system there, you can actually see there's a soft button called teach-in, and that makes that teach-in.
Understood.
We can't do that on the push button panels. We can do it on the monitor systems.
On
Can the
installation,
LED be exchanged out? Can they be changed?
Once again, please.
The LEDs on the light heads, are they serviceable?
Nope, they're not. If you look at the light, you can see it is simply potted here. It's filled up with resin. So there's nothing one can do. If something happens, or when it's getting too old, you can throw it out. They are absolutely 100% resin filled. That also means that it's basically the same models we supply for submarines because they're waterproof. There's nowhere the water could go.
on installation,
But we can't repair it.
on installation, can you share negatives within the light? Between the two lights? Are you worried about current loops or anything like that where you have a 3-wire setup and you're using 2 positives and 1 negative?
Yes and no. I would like to say no because we actually, the LMRQs are interrupting both plus and minus in the wires as we're supposed to. Just like when you had the old-fashioned relays doing that, very often you would have to, but regulations would require you to break both plus and minus. If it's a common minus, the LMR will get confused because now you can see there's something happening on the minus side, which is monitored. It's quite sophisticated actually. But having said that, we do see 3-wire installations, especially on Navy ships for some odd reason, where we have a common minus and 2 pluses going out to the 2. And so we have a version of that LMRQ that can handle that. So on a new installation, it would never be allowed, but on existing installations where it is 3-wire, we can handle it, and it works on US Navy ships actually.
Are there alarm outputs that could be sent to, say, the ship's monitoring system from that system?
Yes, we have the NMA way, but on the web server actually, the one there's a relay that will pull. No, it releases if there's an alarm condition. So you have a firm potential-free relay that you can detect in case of any alarm. We also monitor both primary and secondary power supply in the NLC. So if something happens to one of those, that will also generate an alarm that can be shown. If you can still see the glass bridge thing here, if I now introduce an error on the either primary or secondary here. No, we don't do it here for the demonstration. No, I can't show. But normally there will come an alarm if that happens here. But I cheated.
Okay.
I cheated with the demonstration software. I can tell you that. Show that here.
So the alarm that's sent out is a common alarm. It's one alarm that says something's wrong with the panel that can be sent to, say, a ship's monitoring.
Yes.
Okay, thank you.
Good stuff. Any more questions, guys?
One more. Within the NLC, do you have basic NLC? Do you have the 0183 output? Somewhere in that box?
In my output.
In a basic NLC?
Yeah. There's definitely, and I can send you if you just send us a little mail, I can send you the protocol we use. So if you see the basic system here, there's simply another where is it there?
I got
There's
you.
another sub-D connector here that holds it's an RS-232 output for the
Okay, that's
for
what
the
that's for.
NMEA,
Okay.
and here, and this one we have the RS-485 for the communication with NLC. So it's simply just put it in there.
Understood. Thank you.
So you can daisy chain multiple NLC units off of that one. Is there any limit to how many nav? I know I can't imagine having more than maybe 2 or 3, maybe down in the engine room. You'd want to have a nav light controller as well. But is there any limit to keep daisy chaining these?
Nope. You can put up as many as you like. 50.
Now, going back to that double-ended ferry, the minute let's say the ferry is headed towards Staten Island, the minute the captain on the vessel presses the Staten Island nav light controller, does that automatically send controls to that particular nav light controller? And the New York side of the wheelhouse, if you will, and that nav light controller is then rendered useless?
No, they are a mimic of each other, and what they have on that installation, if you see the group buttons here, they have one group button that we just call underway to Staten Island or underway to New York, and they can be set up so they toggle. So they press underway, and then a certain pattern will appear on the relevant pattern will appear on these indicators here, and when they change direction, they just press, now we're going Staten Island, and then it will turn on complete other set of lights.
Hans spørgsmål var, hvilket panel er på den.
And the two panels, they are absolutely mirror of each other. So if you turn on one end and you go to check status on the other end, you will see exactly the same pattern and the same indications on the directions.
If there was let's say the primary starboard side on the Staten Island ferry direction, would both panels alarm and both give a physical indication, or only the one that's facing towards Staten Island at that time if they had a failure?
They're 100% mirrors. They would both make an alarm, and you can so you get all information on both of them, and you'll hear the alarm and you can see the alarm on both.
Understood.
Can you go over the 3-wire again? I think that was Tony that was asking that question earlier. And that would be a military application?
That's where we've seen it so far. There are many fantastic installations on the old ships to where, I saw one example where they have a 3-phase AC system, and one phase was on the hull, and then you had just 2 phases out. It makes it very easy because with just 2 wires, you can drive any 3-phase huge big AC electric motor because you have 1 phase on the hull. So if they have 3-wire systems and authorities, they can accept that we can easily adapt to that. It's not a problem at all. It's just it's not a modern way of doing it. So it would never be done in a modern installation. But for existing systems, if it's there, we can easily do it, even with ice class installations. Which is something different. Ice class, if I take just 1 minute here, we'll make another seminar on that. It's quite interesting because ice class ships, it's becoming, we're seeing a lot more interest over the last few years of that. It means that we have a little heating element, resistor, sitting inside the light. You can't tell the difference from the light. You can't see anything. We just have a plus and a minus into it to fire either primary or secondary. It's thermostat controlled. So it will only cut in when we're coming close to the freezing point, and we cut out again a few degrees higher. So we have some slack in there. It will of course use we burn some 20 watts at 24 volts. So we're close to 1 amp on top of what the light is using when this thermostat controlled function is hooking in. And that's one thing that's very good. That's very understandable. That it will by itself see to that it's warm enough. And the LMRs, they can handle that because they're prepared to see this ice consumption, which is special, but we know exactly what's going on. But we have actually a very special little principle that's interesting, because we made a system where we can reverse. There's some extra electronics in those ice lights, but we can reverse. Normally we have plus and minus or off, and then we can reverse polarity. And that means that the light will sense, or the microprocessor and the light will sense that now I'm getting power, but it's actually reversed. So it will hook in not the LED array or the LEDs, but only the ice class heating element. So we can de-ice lamps that are actually off without installing new cables, because we use the two existing cables, two or three existing cables going out to a certain, or 3 or 4 existing cables going out to the same position. So that's a smart thing there, and we would like to make a proper presentation one day, because it is very smart that the lights that you don't use right now, but it could be that you would need them and they would be under a foot of ice because it's icy conditions, and you would all of a sudden you would need your it could be your fishing signals, your shooting or hauling signals, or your not under command lights that you show if your net is stuck in the bottom, but then the light would already be ready to show the intensity it's supposed to, and not having to thaw up first. So that is quite an interesting part that we can control with exactly the same hardware we've seen here before. It's just another version of the light, because we don't build these heating resistors into any light sold in the tropics.
Can you show us if a light actually fails and it has to go back, or we have to order a new one? What exactly is sent to us, and does it marry up to the base? Is it just an automatic replacement? If you got a stack light right there, what exactly do you get if you do a warranty claim?
So,
When we're working in a service environment, as a precautionary measure, we will send a complete light for a professional vessel like this. With the base, with all the paraphernalia, in case there is water ingress, corrosion, whatever. In theory, we could send the light unit only, but we just don't think it's smart in the current terms, because the risk of saying, well, that was about not what I wanted, and the vessel is stuck for another couple of days. We do have inventory in the U.S. We can serve you on a day-to-day basis in case of any kind of emergency. There's a 5-year warranty on the lights, and they are designed not to fail. But as we know, things can go wrong, and we also have had issues with things like water ingress, where they've come in through the cable glands or whatever. But we will help, and we are sailors ourselves. We know ships have to sail, and if we have an issue, we'll solve the issue, and then we will barter afterwards. So you can count on that. We've been monopolizing your time for nearly 2 hours now. We really appreciate that you stuck around. That's impressive. We're very happy to share all this information with you. We can talk until tonight, and but there'll be more of these webinars, and we'll probably also be better prepared. Apologies for the hookup, for the problem with the webcam. We thought we had it all under control. you saw differently. But I think we came through in a proper way. Really appreciate your time. What we will make available to you as an email is a copy of the presentation. There's a wire sizing diagram that we have to answer one of the questions that was asked. The NMEA protocol and some other tidbits that could be of relevance. And if you have any feedback for us, we also would appreciate that. Be gentle with us, please. It's the first one, but so you are on the Virgin Cruise here. But yes, thank you very much, and we'll take it down from here. Thank you.